So good morning to all. Let us continue with projection of lines. So our main objective was to solve a case to find the true length of a line if that true length is inclined with both HP and VP. So we know that this true length inclination with HP is denoted by theta. So theta is the angle made by true length with HP, and you can see this theta only from the front view. You cannot see theta from the top. Similarly, the angle made by this true length with vertical plane is called as 5. So we know that this angle is called as 5, and this 5 can be seen only from the top view. So we have seen 4 cases: case 1, case 2, case 3, case 4, and the diagram what you can see here right now belongs to case 4. So what is our objective? All of you look in the front view from here. This is the front view. In the front view, this length, the red line, can be seen as apparent, that is, the projection is smaller compared to the actual length. So in the front view, this length cannot be seen as true length. In fact, when you project A and B, you can see apparent length front view on the vertical plane. So let us make it clear what is our first objective. Our first objective is that I want to see true length in the front view. So this FV length, I want to see FV length equal to true length. So I want to understand that in the front view, when you look in the front view from here, both the length should be equal. Then what has to be done? Okay, so right now this is greater length, this is little smaller. I want to see true length in the front view. So this red line length must be equal to the black line length from the front. So what we need to do? So the solution is, if you look at the actual line AB, we can do one thing. Let us keep point A fixed. So I will fix point A. Fix in the sense I will not allow point A to move anywhere. And point B is the free end, means it can move anywhere. So consider a line AB where one end is fixed. Let A be the fixed point and B be the moving point. So you can now very well observe, look in the front view. I want to see true length in the front view. So what one can do is, let us keep theta constant and rotate point B. So say I am rotating point B. Now the question is, how much should we rotate? So we need to rotate point B unless this line is parallel with, so both the, unless theta, or you can say, okay, first let us rotate. So I need to rotate till here, isn't it? So I need to rotate true length unless and until this 5 becomes 0. So right now you can see both the lines are parallel. So 5 is 0. There is no angle 5. Now when you look in the front view, this length, the projection of this length falls here. And so when you project point B from here, okay, let me project point B carefully. Okay. So when you look in the front view and look at B, point B projection falls here. Yeah, so let us see once again. I want to see true length in the front view. So what you can do is keep point A fixed and rotate B. So when you rotate B, how much you have to rotate? You need to rotate unless the line becomes parallel with VP. Or you can say unless phi becomes 0. But you have to keep theta constant. So don't change theta and reduce phi unless and until it becomes 0. So what is going to happen? Look in the front view and focus on point B alone. So when you focus on point B, so we need to rotate this to assume that you are rotating point B. Okay, so in the front view, this moves out and this line true length becomes parallel with VP. And when you look in the point B in the front view now, so point B is slightly shifted, and when you project till here, you can see that the length, and if I join with A dash, the length is slightly increased. So that is the true length. Okay. So in a nutshell, if I want to see true length in the front view, what is the only condition? The only condition is that this true length should be parallel with vertical plane. So if you can make a true length parallel with vertical plane, you can see true length in the front view. As you can see in case number 1, this length is equal to this length because they are parallel. Same thing over here. I want to see true length in the front view. So this is the front view. I want to see true length from the front view. So very simple, keep point A fixed and rotate B unless this true length becomes parallel with VP, and that is how you can see true length from the front view. Now our objective number 2, I want to see true length from the top view. So what can be done? So let us go to case number 3. So this was case number 3. It says that if I want to see true length in the top view, the condition is that this true length must be parallel with the horizontal plane. So if the true length is parallel with horizontal plane, then both the red and black lines are equal, as you can see, and you can see the true length. So apply this fundamental here. So if you want to see true length in the top view, right now what is happening is this true length and HP, they are not parallel, they are inclined by theta. So what can be done is keep point A fixed, okay, keep point A fixed, and we will rotate point B. So point A is kept fixed and we'll rotate point B unless this line becomes parallel with what? HP. And then when you project this further on HP and if you join with A, you'll get the true length. So that is how it becomes parallel. So two important concepts you need to learn thoroughly. Number 1, if I want to see true length in the front view, keep point A fixed and rotate B unless the line becomes parallel with VP. That is how you can see true length from the front view. If I want to see true length from the top view, concept number 2, keep point A fixed and rotate B unless the line becomes parallel with HP. That is how you can see true length from the top view. So these are the two main concepts to solve any numerical on lines. So while learning these two concepts, one more thing has come forward which we have to understand. Okay, so here suppose this point is A and this point is B. Okay, this is the true length, and as you can see here, there are two planes, VP and HP. So as I told you, if I want to see true length from the front view, you need to rotate B. So if you carefully observe, the point of rotation of B is somewhat like this. So if you look in 3D, it will look like an ellipse, isn't it? So point B will rotate like this. But you are not supposed to rotate fully in a circle. You need to rotate the point B only till the line AB becomes parallel with VP. So the new thing what comes out over here is, what you have to learn is, if you look at this circle, so in the top view, when you look at the circle in the top view, so in the top view you can see there is a circle, projection of a circle what you get in the top view. But if you look at this circle from the front, what will you see? So you learned in orthographic, any circle when you project in the front view. So let me project this in the front view. So when you do so, you are going to get a straight line. So when point B travels in a circle, in the front view that circle will seem to be straight line. In the top view that circle seems to be a circle. So this straight line is called as locus. So what do you mean by locus? It is the path traced by a moving point. So this is the locus of, let me call B dash. Why B dash? Yes, because you are looking at this circle from the front and the projection of B in the front is always B dash. I hope something is clear, right? Now if you look in the top view, you will find a circular locus. So this line is called as locus of small b without dash. So whenever a point travels in a circle but from the top view, you can see circle in the top view, that is the locus, circular locus of B. But in the front view, that circle will be seen as a straight line locus, but of B dash. Okay, so this part is clear, right? So best example is the ceiling fan. So when you look at the ceiling fan, so if you look from top or if you look from bottom, it will look like a circle. That is what it is. But if you look at the blades from the front view, suppose if you climb up a stool and look at the blades of the ceiling fan, of a rotating fan from the front view, it travels in a straight line only. Opposite, you also need to learn this part. Okay, so suppose this point is capital A and this point is capital B. Suppose this is the true length of the line. This is the true length of the line. Okay. Now I wish to see true length from the top view. So as we have discussed, if you want to see true length from the top view, what you have to do is that rotate this point B unless this line AB becomes parallel with what? HP. So this is our HP and this is our VP. So if you want to see true length from the top view, you need to rotate this point B unless this point becomes parallel with HP. Okay, so now if you look in the front view, this point B travels in a circle. So the projection of this B in the front view, you can see a circular locus. So now it is the other way around. Now in the front view, you'll get a circular locus of B. But if you look at this circle from the top view, and if I project this here, so let me project the circle here, you're going to get a straight line locus. Now because this locus is from the top, it is locus of small b without dash. It is without dash. Okay, so hope these concepts are clear. So these two things you have to visualize. When a point rotates in the front view, so I am rotating this point from the front view. So front view will be seen as a circle, that is a circular locus, but top view will get a straight line locus. And other way around, if a point rotates in the top view, so top view will be a circular locus, whereas the front view will be a straight line locus. Okay. So the best example is merry-go-round. If you look at the merry-go-round in the front view, when you stand here, suppose if you're standing here and looking at the merry-go-round, you can see that all the baskets are traveling in a circular direction. Same thing observed from the top view, you will find a straight line locus. Okay, so both these points are clear. So if I last minute revision once again, let us revise for the last time. If I need to see true length in the front view, what is the procedure? Keep point A fixed and rotate point B unless the line becomes parallel with VP, or you can say unless phi becomes 0. That is how you can see true length from the front view. Now if I want to see true length from the top view, what is the procedure? So the procedure is keep point A fixed and rotate B unless the line becomes parallel with HP, or you can say unless theta becomes 0. So a very simple concept, out of theta and phi, one angle needs to be kept constant and the other angle you need to rotate unless it becomes 0. That is the fundamental for understanding lines. So two concepts you should be thorough with. Okay, now suppose for time being, assume that this true length is being removed, then the diagram will look like this. So if I remove the true length for a while, so here the true length was over here, this point was A and this point was B. So the true length was somewhere the line joining AB. If I remove true length for a while, you can see that the front view A dash B dash is attached with the vertical plane and the top view AB is attached with the horizontal plane. We also know that when I rotate HP, when I turn HP or when I operate the plane, HP should always be turned in this direction. So carefully observe now, when you turn HP in this direction, this is the diagram what you're going to get. So compare both the diagrams. So front view will remain above XY. Front view will remain above XY. Now because you have turned HP down, HP will come in the downward direction, isn't it? And along with HP, top view will also come down. And this line is the XY line. So in first quadrant you have to remember that front view is always drawn above XY on vertical plane and top view is always drawn below XY on horizontal plane. A dash B dash above XY, AB below XY in case of first quadrant. So look at this diagram from here. You can see this diagram now. So this is the view. So if you look at this diagram from the front side, okay, so front view is above xy, top view is below. So that is what I have drawn. So now onwards diagram will be shown like this. This is the xy line. We will not draw a rectangle above, not required. So you have to visualize that everything above xy is nothing but the vertical plane, and everything below xy is the horizontal plane. This you have to always visualize. This is for the first quadrant. Okay, so this is the front view a dash b dash. This is the top view ab. Can you make out where is dbp? So what was the long form of dbp? So dbp stands for distance between end projectors. So as you have seen here in this diagram before also, a dash and a lies in the same level, because here also if you see a dash and a are in the same level. Similarly, b dash and b will also fall on the same level. So here also b dash and b will fall on the same level. So what was dbp in that case? So if you extend the projector of a and projector of b, so we have seen earlier that this horizontal distance is called as dbp. So here also this is the projector of a and this is the projector of b. So this horizontal distance between both the projector, this one, so this horizontal distance between both the projector is called distance between end projectors. Okay, so hope this diagram is clear. Now what is our next step? Our next step is, you know that this is front view and this is top view. So I want to see true length in both the views. Even here I want to see a true length. Even here I want to see a true length. So by this time, one concept is clear to all of you, that if you compare the length of true length front view and top view, which is the longest line? Yes, so longest line is always the true length. Front view and top view is a bit smaller. So here I want to see true length in both front view and top view. So obviously true length will have a longer line. Even here you will get a true length of a longer line. So how to get the true length is our next thing. Okay, now so as to get those two true lengths, one in the front view and one in the top view, we need to follow a different concept. What is that? Look at this diagram, the first diagram. So here we are assuming that the actual line AB is missing, that is the true length is missing, and you're left only with the projection of the true length, that is front view A dash B dash and top view AB. So now this diagram I have split it into two parts, first and second. So as you know that in mathematics you have formulae to solve any numerical. So in this topic lines, these are the two formulas. So we will call this formula as tool 1 and this formula as tool 2. Now this formula is not a mathematical formula. It is a formula which is obtained by drawing. So if you draw certain lines, you can derive those formulas. So today we are going to understand which are these two formulas. We are going to understand logically as well as we need to by heart it. If a student has thoroughly understood and if he remembers all the standard things for both these formulae, then he or she can solve any numerical or any word problem on this topic. Okay, so let us carefully analyze. So what I am doing here is, this diagram I have split into two half. How come? Look at this AB. This AB I have drawn over here at tool 1, and this A dash B dash I have shifted to tool number 2. Later on we are going to merge both these tools so as to give you this diagram. So I hope it is clear. Now we know that HP should always be turned down. We need to always turn HP down, isn't it? So when you turn HP down, this is what is going to happen. So let me little bit zoom. Okay. So what has happened is, after you turn HP down, see from now onwards diagram will be shown like this. This is the XY line. You should know that everything above XY is vertical plane and anything below XY is horizontal plane. So the portion above xy, the space above xy is the vertical plane and below is the horizontal plane. So after you turn HP down, so what is going to happen is front view will remain here only and top view will go below xy. So I have drawn top view AB below and A dash B dash is above. Now let us split the diagram. So this top view I have transferred here. The front view is blank. So if you turn this diagram, so tool 1, so this tool 1, a little bit inside. Okay. So this tool 1 correspondingly, so this is the 3D diagram, 3-dimensional drawing. So if I turn HP down and if you look from the front, this is how the diagram will look like, isn't it? So top view will go below xy. So here top view is below, and we should again remember that anything above xy is VP and below it is HP. So this part of the diagram front view I am drawing somewhat above, and this diagram is the 2D effect of this part. So when you look at this diagram after opening HP in the front, you can see front view above. So that is how the front view is above and top view is vacant. Okay, so if you look at both these diagrams, this is the 3D part and this is its 2D. And if you look at this part, this is the 3D part and this is its 2D. So we can say that this is tool number 1 and this is tool number 2. So now what are these tools and how to understand? Let us start with now. So what is our object? I'll remind you once again. In tool number 1, I want to see true length in the front view. So given a top view of a line, I'm supposed to see true length in the front view. How to do that? Objective of the second tool, given the front view of a line, I want to see true length in the top view, opposite of converse of the first one. I want to see true length in the top view. Then how can we achieve that? That is our main objective. So only few minutes more to understand and clear the concept. So for tool number 1, let us take a practical example to understand tool 1. So suppose you have a ceiling fan. So this is the base of the fan. Okay, this is the rod. And suppose one of the wings of the fan is somewhere here. Okay, so this is the wing of the fan. Now to understand tool number 1, let this point be capital A and let this point be capital B. Okay, so carefully observe this diagram. Okay. Now next step is look at this diagram from the front. So if you project and you are supposed to look only at the wings of the fan, or you have to look at the blade of the fan. So when you look at the blade of the fan, and if you consider this blade as a line AB, so look at this part and this part. So when you look in the front, you can see the length of the wing as an apparent length. So you can see A dash B dash has a small length, isn't it? You can't see the exact length because the wing is inclined. So the question is, if I want to see the exact length of the wing, what am I supposed to do? So logical thinking, keep point A fixed and rotate B. So I need to rotate B. So try to visualize, you need to rotate B. So my question to all of you is, in which view can you see the circular rotation of this fan, circular movement of the fan? The answer is obviously from top view, you can see the circular movement of the fan. Now the question is, if I want to see the exact length of this wing, how much I am supposed to rotate? So suppose if I rotate the wing by say small amount. Now try to analyze. So point A is here because it's a fixed point. Now B has occupied this position, isn't it? Now when you look in the front view, point A projection will lie here itself, but B has slightly extended. So the length of the wing is slightly more. When can you see the exact length? So logical thinking says that when the direction of viewing and the blade of the fan, they are parallel, or you can say when the wing is parallel with the vertical plane which is imaginary behind, then you can see the maximum length of the wing. So what does the concept says? The concept says that whenever you rotate a point in the top view, see the rotation is in the top view. Try to analyze. The fan is rotating and you can see from the top view. So B has reached here. So whenever a point rotates in the top view, you can see the true length from where? From front view. So the rotation of a top view of a point will lead to the viewing of true length in its front view. Okay. So remember that whenever a point rotates in the top view is a circular locus. But in the front view, that point B will travel in a straight line. So let us start with this part first. So here the same story. I want to see true length in the front view. So the concept is if you rotate top view, you can see true length in the front view. But before that, taking the example of this fan. So whenever you rotate top view, the front view is a straight line locus. Whenever you rotate top view, the front view is a straight line locus. So what we'll do here is in the front view, we will draw a straight line. So I will draw a light straight line in both the planes. Okay. And the name of this locus is called locus of. Now see, the moving point is B and you're drawn this in the front view. And front view is with dash. So this is locus of B dash. See even here, this line passes through B dash only. So this is locus of B dash. So I've drawn in both the views because we are supposed to merge later on. Now coming back here, what was the concept? The concept was if you rotate top view of a line, you can see true length from the front view. So let us apply that concept here. So carefully look at this drawing in 3D. Okay, before that one more thing is being left out. What is that? Okay. So this locus of B dash is seen as a straight line from the front view. So in these two diagrams, okay, one more thing, that same locus in this diagram is passing through B dash. So what I'm supposed to do here is from B dash parallel to XY. Okay, parallel to XY, from B dash, I'm supposed to draw a light line. Okay, and what am I supposed to write above? Locus. Locus should be written in capital. Of B dash will be small. Okay, so that is how locus has come out because of the fan concept. Now, carefully look at this diagram again. So I want to see true length in the front view. So the objective of tool 1 is to see true length in the front view. Then how to do that? So now look at the concept. All of you look in the front view. Project this point A. Project this point B. You can see this much length of AB. So the black line is seen apparent in the front. Is this true or apparent? Yes, it is smaller. So it is apparent. You want to see true length. So what does the concept say? Keep point A fixed and rotate B. Now how much you are supposed to rotate? So rotate point B unless it is parallel to XY. Or you can say unless it is in level with A. So let us rotate B. But till where? Till it is in level with A. So when you do that, what will happen? Point B has rotated, moved and it has reached here. Now when you project this point and look at AB, the length has increased. So that is how you have found the true length, isn't it? So now you have rotated AB, right? So what you should do now is, because you have projected A dash, now this point you transfer here and then you project here. So on the locus you will get this point. Now that point, if you join with A dash, you will get the front view. Sorry, you will get the true length. So if you rotate top view of a point and project it, you will get the true length in the next view. So this concept you need to learn. Now furthermore, if you turn HP down, and same concept if you apply here, what am I supposed to do? So first of all rotate top view, but till what level? Till level of A. So look at this diagram. So in this diagram, point A is fixed and B is moving, isn't it? So I need to look in the top view because below XY is top view. So in the top view, keep point A fixed and rotate B till the level of A. So here I'll take this compass. I'll keep compass at A, needle at A and the point at B, and I'll rotate light till where? parallel to xy or to level of A. Now say I've done that. What is the next step? After you reach here, you need to project this point to cut the locus of B dash. So after I reach here, I need to project till the locus of B dash. So parallel to A dash, I need to transfer this. Okay, I need to transfer this till here. So after you reached here, you're supposed to join this with A dash. That is how we get the true length. So this is our first formula, what is being derived. So the concept is very simple. Example is fan. So if you look at the ceiling fan, more precisely ceiling fan. So if you look at a ceiling fan, if you rotate the top view of the fan from the front view, its length increases. Okay. Let us now move on to the second tool, which is the converse of the first one. So we will zoom a bit. Yes. Now our objective is to see the true length from the top view. So given front view, how to find the true length in the top view. For that, we need to consider one more example. So for tool number 2, let us take one more live example. You might have visited amusement park like in Mumbai we have at SL World. So from there, if you take an example from there, you can understand tool 2 very easily. So as far as I remember, I visited SL World long back. In that, there was a ride called as Rainbow. So Rainbow was a ride where this was the base of the rainbow. This was the base of the rainbow, and the rainbow had a huge arm. The arm of the rainbow was quite huge. So this was the arm of the rainbow. Okay, and at this point you had a basket where we all used to sit and enjoy the ride. So now you're looking at this rainbow from the front. Okay, so this is the arm of the rainbow, and in our case this is nothing but our line AB. So this point is A and this point is B. So this is our line AB. Okay, so now let us try to visualize this arm from the top view. So if you view from the top and if you project A and B, so will the length of the arm, what you can see from the top view, will it be true or apparent? So obviously the length of this line is longer, this is smaller, so this is an apparent length. What if I want to see the true length from the top view? Isn't it? I want to see true length from the top view. So apply a very simple concept. Keep point A fixed and rotate B. So always moving point will have locus, remember that. Fixed point will never have a locus. So rotate point B. But how much to rotate? Unless it becomes horizontal. Okay, or you can say unless this is parallel with the ground. So when you rotate the arm a bit only till here, so suppose B reaches here, and if you project this point, you will find this length of the arm slightly increases. But when this arm becomes purely horizontal like this, and if you view from the top, this is the maximum length of the arm, what you can see. So the concept of this tool number 2 is very simple. If you rotate front view of a line, so this was the front view because you're viewing from the front. So if you rotate front view of a line, from top view the length increases and you can see the true length. So in which view can you see a circular locus? Yes, in the front view you can see circular locus. What is the top view of the circular locus? It is a straight line, isn't it? So we have seen this before. See, we have seen that when a point travels in a circle, the top view is a straight line. Same thing here. Here the arm travels in the front view in a circle, so top view will be a straight line. Okay, so what is tool number 2? If you rotate front view of a line, you can see true length from the top view. So dear students, please remember these two examples. One is the ceiling fan, which says when you rotate top view of a line, you can see true length from the front. And second is the rainbow, which says when you rotate front view of a line, you can see true length from the top view. So these are the two important examples. Now let us apply that concept here. So assume that this is the arm of the rainbow. So in the top view, when you observe, so all of you look from the top and try to look at this line. This line will be little smaller in length, isn't it? So this line will be smaller in length from the top view. If I want to see maximum length, keep point A fixed and rotate B unless it becomes parallel with XY. So let us do that. So I will rotate B unless this becomes parallel with XY, or you can say in level of A dash. So rotate B unless it reaches level of A dash. Now once you get this point, now look in the top view, you can see maximum length. So the moment you rotate point B, the length increases in the top view. Okay, before that, I forgot to tell you, as we discussed, that point B travels in a circle in the front. So top view is a straight line locus, and here top view means on HP. Okay, so what we have to do is that, as we done the locus of B dash earlier, now we need to pass a locus through B. So parallel to XY, through B, we will draw a straight line locus, and that locus will be transferred here arbitrarily. It will be transferred here. So we'll write this as locus of B. This is nothing but locus of B. And on this side I write down locus. See, locus of should be capital, B should be small. Okay. So why there is no dash over here? Because on HP everything is without dash, because it is a top view. Now coming back. So when you rotate front view of a line parallel with XY or in level of A dash, and this point you need to project on the locus. So how to project that? So from here, if I draw a light line, and then if I extend this further to cut the locus, see, I have done that. So wherever this projector cuts the locus, you will get the maximum length called as the true length, and that too in the top view you can see. So with this two, our formula is being derived. Now what you do is that, zoom in. Okay, so let us open up this plane HP and draw that concept over here. So the concept over here is, if you rotate front, keeping point A fixed, and if you rotate front view of a line till level of A dash or parallel to XY and project down on the locus, you will get A, isn't it? So here, first of all, I will draw a light line locus as I done above, and I write this as locus of B. This is what? Locus of B. Now this front view I will take in the compass. Okay, and I will rotate unless it is parallel, or you can say in line with XY. So this should be parallel to XY, or you can say in line with A dash. Now this point I need to project. So for that, parallel to A dash, I need to transfer this down. So the moment you get this point, you connect that with A dash, you connect that with A to get the true length. So here, this is the true length. So this diagram has come from here. Huh? If I turn HP down, you can see this line here and this one. So this is tool 1. This is tool 2. So remember that we need to merge the diagram later on. Now what is the last thing left before we end with the tools? There are some standard things to be understood, and you need to name them. Okay, now I'll highlight some of the points. This point should be labeled, should be named. Okay, so let us start now. So first of all of you know that now above XY everything is VP, vertical plane. So above XY everything is what? Front view, which lies on the vertical plane, and front view means with dash or without dash. So front view is with dash. So what is the technique of labeling? Let us see. So suppose if I want to give some name to the batches, practical batches, what we generally do is we give name as B1, B2, B3. These are the namings what we generally give. So in engineering graphics for this particular topic, we will name the batches in this order: B, B1, B2, B3. And if it is in the front view, the name of the batches will remain same, but it will be with dash. In top view without dash, in front view with dash. So the name of the batches starts from B, B1, B2, B3. So these are the practical batches what generally in college and in school we used to give. But now in this case what we'll do is that look at this diagram. So we know that above xy everything is with dash. So can you see B dash is already named. So as I told you, the first batch is B dash, the next will be B1 dash in order, next will be B2 dash, third will be B3 dash. So from B dash, move in this direction, I need to name this point. So after B dash, in order it was B1 dash, so name this as B1 dash. Why dash? Because it is above and in the front. Similarly, everything below lies in the top view and it is without dash. So now carefully look here. We have studied in case 1, case 2, case 3. So while studying the various cases, we have seen that the other name of top view is plan length and the other name of front view is elevation length. We know that. So if you look at this diagram, this AB, if I take in the compass and rotate, I am going to get this horizontal line. So we can say that this length AB is same as the horizontal line because you have got this by rotating the line AB. So the length has to be same. So another name of top view is plan length. You should write this as PL. So PL stands for plan length. Similarly over here, this is the front view of the line and this line is equal to this line. So when you take a turn, both lengths are equal. So another name of front view is elevation length. So in this diagram particularly, front view is always inclined and elevation length is always horizontal. Here top view is always inclined whereas plan length is always horizontal. So after B, so how did you name? First A dash B dash is always front view and AB is always top view. So after B dash you need to move here. So this is B1 dash. Okay. So parallelly if I name this diagram, so see in tool 1 this is A dash B1 dash. So here if I name this as B1 dash, suppose this point is B1 dash. Let me name it. This is B1 dash, correct? So now if you look here, projection of A dash is A. So projection of B1 dash, this point has to be B1 because they are the projections. And this top view and this length are same. So this is plan length. So after this what you learn is from B dash, B1 dash. Now look from the top view. Projection of A dash is A. So B1 dash has to be B1. So this point is B1. So how did you name B dash, B1 dash? B1 dash ka projection is B1. Now let me keep a scale here. So everything below xy is top view and without dash. So we have named B, we have named B1, we can't name B1 again. So after B, B1 in order in sequence, this has to be B2. So true length in the top view is called as AB2. So look at this diagram. This is the true length in the top view. So we'll call this point as B2. Now the projection of A is A dash. See, the projection of A is A dash. So what is the projection of B2? This point. It has to be B2 but dash because it is in the front view. So if you look at this line AB2 from bottom, the projection of A is A dash. So B2 has to be B2 dash. So the naming goes like this. After B dash, B1 dash. From B1 dash, B1. B, B1, B2, B2 ka B2 dash. These are the standard namings. You're not allowed to change, interchange or use a new naming. Compulsory you have to use this naming only. Coming to the last part of it, we know that there are 4 angles. There are 4 angles. Which are those? So what was theta? Theta is the angle made by true length with HP and you can see from the front. So this true length is called as theta with horizontal or HP, because we know that this is VP, right? And HP means it has to be folded. HP will be folded like this. So VP is like this and HP comes out. So true length with HP is called as theta. So in the 3D diagram, this angle is theta. So theta is the angle made by true length with HP. So you have to by heart this. Similarly, the angle made by this true length with vertical plane is called as phi. So why I call this as vertical plane? Because see, this and XY are parallel, right? So when you look in the top view, you can see this true length with VP. So that angle is called as phi. So in this diagram, the angle made by this true length with VP or with horizontal is called as phi. Okay. Next, we had also seen angle made by front view with XY is called alpha. So here front view is here and XY is nothing but horizontal. So with respect to horizontal, this angle is called as alpha. The last angle was beta. So here top view with horizontal is called as beta. So we know that this angle in 3D, if you look here, this angle is alpha and this angle is beta. So the conclusion, if you look in the front view, theta and alpha can be seen. And if you look in the top view, alpha and beta can be seen. Sorry, beta and phi can be seen. If anybody wishes to take a screenshot of this, you can do that. So the 3D diagram is very useful. So you can compare this 3D with 2D so as to understand the concept. So now let us learn how to draw both the tools. So all of you on a new page, approximately in the center, draw a horizontal medium dark XY line. So it should be parallel with the edge of the paper. So at any distance, approximately, not exactly, approximately draw a medium dark XY line as you can see here and write capital X. Now how to write capital X? Okay. So that capital X should not, you can't write anywhere. So you should learn the correct thing. So that capital X should be written neither above nor below. It should be written somewhat like this. See here, you can zoom this. So it should be written approximately in the center of this. So for all the word problems that you're going to solve from today onwards, you need to write capital X and similarly capital Y approximately in the center. You need to write Y like this. So please remember this. I need not repeat every time. So that is how capital X and Y are written. So all of you draw a medium dark line and write capital X and capital Y. So we are not solving any word problem right now. We are learning how to draw both the tools which is required here. Okay, so next step now, with the help of this scale, or you can say parallel to the edge of the paper, draw a light vertical line of any length. Vertical line can be light of any length, and anywhere above XY mark a point little bit darker and write A dash. Again, where to write A dash? On the left side and above, and below that mark one more point and write small a without dash, again on the left side and below. You have to mark 2 point A dash and A. So step number 1, draw medium dark XY. You have to learn the steps of drawing both the tools. Draw a light projector, mark A dash and A like this. Okay, once you're done with this, parallel to XY line, just roll this above and draw a light line from A dash and A. Okay, and again parallel to this A dash and A, because we need to split the diagram into 2 parts. So you need to draw this A dash and A 2 times, approximately in the same height. So here at certain distance, you need not measure all this distance. So we need to mark A dash once again above and the left side, below and on the right side. Okay, so once this is done, we need to recollect the tools and learn how both the tools are drawn. So here top view is drawn below XY and front view is drawn above XY. So what you do is that with the help of a scale from point A, draw a dark line, double trace, draw a dark line of any length, any angle. I repeat, any length, any angle. So this point will be small b and this is top view. So you need not measure the length of the line and angle, but it has to be dark. Okay, so let me darken it. Okay. But the length of the line should not be so much that when you rotate, it will interfere with the next diagram. Similarly, front view is dark and always drawn above XY. So here from A dash, you need to draw a dark line of any length, any angle. It need not be of the same length what you drawn before, any length, any angle. And name this point as B dash. And A dash, B dash is called front view. How to write front view, you should write above the line and along the line. So FV should be written like this and TV should also be written above the line and along the line. Okay, so that is how top view and front view are ready. So once again revision, what is the first step? Draw medium dark XY. Okay, so step number 2, after you drawn medium dark XY, mark A dash and A as you can see here of any length. Project this A dash and A further. For the second diagram, mark A dash and A again. Once you've done this, from point A, draw a dark line of any length, any angle and write TV above and name this point as B. Similarly from A dash, draw a dark line A dash, B dash and write FV above, also write B dash. Next we have seen that from point B, we need to draw locus of B, which is a light line. And from point B dash, we need to draw locus of B dash, which is again a light line. So parallel to XY, we will slide this down and we'll draw a light line covering both the tools. So the length should be such that it should cover both the tools. Similarly from XY, we will roll this up and we will draw a light line covering both the tools. So now above the line, above the line in capitals you need to write locus of B, B dash and so on. So here anywhere on the line you can write. So let me write here, let us write here locus. See, locus should be capital, equal font size and B dash should be smaller. This is locus of B dash. And here I will write down this is locus of B. So at any given point of time, if I ask you to draw both the tools, you should know how to draw. Okay. So first XY, A dash A 2 times, top view, front view and 2 locus. Now let us learn or let us draw how to operate tool number 1. So we will call this as tool 1 and this is tool number 2. How to operate tool number 1? So very simple, given top view, rotate top view till the level of A. The correct word used is level. So rotate top view till level of A and project on the locus of B dash, you will get true length. So this is the concept of a ceiling fan. So if you rotate the ceiling fan from top view, you can see true length from the front view. So when this rotates in the front view, what will happen? This length of the projection between A and B will increase. So when the top view rotates, the projection between A and B will increase and that you can see from here. So that is nothing but front. So on rotating top view, you can see true length from the front view. So take a compass with A as center because A is the fixed point and B is the moving point. So only moving point will have locus. So rotate B till the level of A. This rotation should be shown lighter, as light as possible. So when you with keeping point A fixed and when you rotate B till the level of A, the correct word is level. This length is called plane length because other name of top view is plane length. You get a point over here. So this point you need to project further to cut the locus of B dash. That is how you get the true length. So our objective is to get true length only. So from here you need to project this point to cut the locus of B dash. So when it intersects here, this point has to be joined medium dark with A dash. So join this medium dark with A dash. So it should be medium dark, a bit darker, okay. A medium dark with A dash. This is our true length. Okay, so top view should be dark, true length should be medium dark, rest all the lines including the curve should be lighter. Now swap the tool, you will get the next answer. So on doing that, now you have front view of a line and you want true length in the next view. So this is the arm of the rainbow. So when you look in the top view, you can see, and if you project A dash B dash, the length is smaller. I want to see maximum length. So simple concept, keep A dash fixed and rotate B dash. So when you rotate B dash and when you project it, the length of the arm goes on increasing, isn't it? So try to visualize. Initially A dash B dash was smaller. So when B dash rotates, the length of the arm increases. Maximum length you can see when this arm is parallel with XY. Okay, so take A dash B dash in the compass. A dash is the fixed point. Rotate B dash light, but till where? Compulsory till level of A dash or parallel to XY. So by doing that, the next name of front view is elevation length. Write EL over here. So the concept is when you rotate front view of a line, you can see true length in the top view. Now this point I need to project down. So align your roller scale here and extend this point down to cut the locus of B. So wherever this projector cuts the locus of B, that point you join medium dark with A. So this will give you the next true length. Okay, so by mistake I have made a dot here, so this dot will not be there. Okay. So these are the two tools what we have prepared. Now only preparing the tool is not sufficient, you need to label it. So after B dash, the next point to be named is here. So everything above XY is dash for first quadrant. So after B dash, this point will be B1 dash. So this point is B1 dash. Now if you look at A dash B1 dash from top view, projection of A dash is A, so B1 dash has to be B1. So don't name B2 immediately. A dash projection is A, so B1 dash has to be B1. Now everything below XY is without dash. So after A, B, B1, we can't name B1 again, so this has to be B2. Now look from this side. Projection of A is A dash, so B2 has to be B2 dash. Okay, finally we need to name the four angles. So you have to remember by heart that A dash B1 dash true length can be seen in the front view and it always makes theta with horizontal. A B2 another true length can be seen from the top view and it always makes 5. This you have to write with pencil only. Always makes 5. With what? With vertical. Now front view always makes alpha with XY and top view always makes beta with XY. Okay, so we will label this as tool 1 and this is tool 2. So each and every student have to thoroughly by heart the namings, the angles, the procedure to draw, and if you know this thoroughly you can solve any question on lines. Is it clear? So below this you need to write down few notes. Number 1, front view FV and TV should be drawn dark. Second point, true length TL should be drawn medium dark. So if I ask you logically, why top view and front view should be dark? Because orthographic had taught us always the views are dark. Your drawn front view, top view, side view dark. That's why. Why true length should be medium dark? So true length means actual line, and actual line is not physically present. It is imaginary, and imaginary lines are drawn medium dark. Third, rest all lines should be lighter. So you should thoroughly remember this while learning this topic. Last, if I ask you where is the distance between n projectors in this diagram, then what will be your answer? So you should remember that we have splitted this. You need to rejoin again. So when you rejoin this A dash, so what you do is that assume that this part is a slider. So you slide this back. So when you slide this back, A dash will coincide with A dash, and this A will coincide with this A. So this front view will be somewhere here. This front view will be somewhere here. It will slide back. So B dash will get shifted here. So finally what you'll understand is, when you slide this back, A dash B dash will get shifted here. And this is the true length, right? So this A dash and A will lie on the same projector, and B dash and B, see this B dash and B will also fall on the same projector. In short, as ortho has taught us, front view and top view lies in the same level. So this front view and top view lie in the same level, and the distance between these two projectors, this will be our DBP. Okay, so hope you got this. So DBP won't be understood if it is drawn separately. You need to merge both the diagrams. Only then you'll find DBP. Okay, now before we start with our word problem, this is our XY line, and as I told you, everything above XY is VP and front view, and below XY is HP and top view. So let me fold the paper about XY. So we'll fold this paper. Okay, now after I have folded, see I have folded over here. So this plane is what? HP, and what you can see it as a line is VP. So you should remember that top view beta and true length 5 you can see from the top view, and when you turn and look in the front, you can see true length theta and front view alpha. So actually the paper is being folded. When you open and draw the diagram, it will look like this. Once again, VP is always here and HP is horizontal. So in the top view, now I am showing you the top view, you can see beta and 5 and everything without dash. But when you open HP and consider this to be on one single plane, this is how the diagram looks like. And now what I am showing you is the front view, right? So in the front view, HP is seen as a line. So HP and the green XY will overlap in the front. So you can see true length theta and you can see front view alpha both together. And everything is with dash. So this concept you need to understand. Top view, VP seen as a line. Front view, HP seen as a line. Okay.